Hi everyone and welcome to the video today on the quotient rule. In these videos I'm going to go over how to use the quotient rule, and we're going to use it to do some fairly nice proofs as well. Now the quotient rule, as the name implies, is used just for when we have a quotient of functions. So quotient meaning that we have one function divided by another. And so you can see I've written out the different ways of displaying the quotient rule. So here we have the way we'd write it using Leibniz notation. Okay, this is, in my opinion, the nicer way of remembering it. And over here, well, yeah, we've got that mess, which I'm not particularly fond of. So, anyway, let's just jump into it. So we're going to have a look at differentiating these two equations. And you can see right away that it's not actually working. Just give me a second. Okay, hopefully this is better now. Let's see. Nope, still not. Oh, there it is. Okay, just taking its time catching up. So let's differentiate these things. So you can see right away we have a quotient of functions here, and in doing these, like, we could always do them, using some long division or something like that. But basically, that's going to be a real pain. So this is a method which is going to enable us to differentiate without having to go through all that extra work. So what I'm going to do is I'm going to make so that u is the function in the numerator and v is the function in the denominator. So in this case, u equals x plus 3 all squared, and v is equal to x to the 4 minus 3x cubed plus 5x. So I can differentiate each of these to get du dx equals 2 out the front of x plus 3. It's going to be multiplied by 1, so it's just going to stay like that. And dv dx is going to be 4x cubed minus 9x squared plus 5. Right, so now we're good to sub it into the rule. And the rule, which you should write down just to help get stuck in your memory, is v du dx minus u dv dx all over v squared. Again, with this rule, there's a nice reason for that being the case, but I'm not going to go into that in this video. So, subbing everything in, we've got v times du dx. Perhaps the nicest way to write that would just be 2 and then x plus 3 and then 4x, x to the 4 is what I meant to say. So x to the 4 minus 3x cubed plus 5x. Okay, so it's v du dx minus u dv dx. So that is 4x cubed minus 9x squared plus 5 out the front of x plus 3 all squared. And that has to all be divided by v squared, which, well, that's not going to be anything nice at all. So it's just x to the 4 minus 3x cubed plus 5x all squared. And that's as far as we'll go with that. I suspect that I'm not going to get through this next question in the remaining time that I have on this video, so we'll just stop this one here and pick it up in the next one.